Hello people, welcome back to my channel. The topic for today's video is decision boundary of a neural network. So in the last videos we saw the matrix representations and many other different forms that we mainly use in deep learning. So in today's video, let's see how a decision boundary looks like in neural network. Now we have learned in different algorithms including decision trees and linear regression and many other. That is, we have a specific kind of decision boundary for each of the data set, and it depends upon how the input distribution is. So in neural network, there is no particular kind of decision boundary that is general for each and every instance that which it incurs. Instead, as and when how the data comes, it will learn the decision boundary as it is. So say for example, now since I have this axis, and say if I have some instances, say like this, and I have some more instances like this. That is, this is a two-class problem. So now what you can see is the distribution of the data that is homoscedastic, means that is uniform across the two separations. Now if I ask you like whether I can draw a decision boundary that can well separate these two different classes, so I can essentially say like I can draw something, a decision boundary like this, where equation of this is equal to y is equal to of the form x. So where y minus x is less than 0 on this side and y minus x is greater than 0 for this other class. So essentially in 2 dimension you can see this as a line, but in 3 dimension you can assume this as a plane that is separating these two. So whatever instance lies on the upper side, that belongs to this cross or the black class, and whichever falls below this plane, that belongs to this blue class. Now say for instance we have some another setup. So in the real world you don't have the data set all in linear formation, so there can be non-linearity also, so that's why we introduce the non-linear part. So we'll come into that a bit later. So now say our distribution is, say like we have now the points laid in this way, and we have some more points which are say of this class. Now this class is somewhat homoscedastic, means it is uniform, but the lower class which is there, that is for the blue, it's not uniform, but there is some kind of particular curvature that is following. So essentially we cannot put a straight line that passes through or that separates these two classes. So essentially what we can have is, we can have a decision boundary something like this. Now this particular decision boundary is not linear, so it is a parabolic curve. So we are mainly doing the curve fitting, that is of the form y is equal to x square. So essentially you can see that this particular looks like a bowl shaped in 3 dimension. So where for the cost function for linear regression you have the slope and the intercept. For neural networks you have the weights as well as the biases. So neural network will also learn this kind of decision boundary. And then you have some another setup. Say you have some points which are there inside this, and say you have some points which are there outside. Say I'll just take the triangle glass. This is how the data distribution is. Now you cannot draw a straight line which separates these two, neither you can draw a parabolic curve fitting. So what you can essentially do is you can draw a circle, so which is of the form x square plus y square is equal to a square for some constant, and for the classes which lies inside, x square plus y square minus a square is less than 0, and for outside this equation becomes x square plus y square minus a square is for this inside it's less than, for outside it is greater than 0. That is for points lying on the circle, for that you have this equation of a circle, and for points that lie inside the radius or this particular value is less than 0, and for outside it is greater than 0. So now you can see different types of decision boundaries are there across different algorithms. So you need to make your neural network learn these all decision boundaries. And so if your equation, if you remember, that is we have, that is the linear part, when we compute w1 x1 plus w2 x2 up till you have wn xn. So this was the linear part that we were computing in this particular unit. So then we have some non-linear functions. So mainly we would use a sigmoid function so that it transforms into some essential formation. So now say your neural network is just learning only this particular linear function, but then now each and every time it is classifying your instances in this way. And if some distribution comes like this, then it is unable to classify this. Why? Because it is just only learning your linear part. So that's why you need to have a non-linear function. So we drew some equations, x1 x2, then we had the bias as well, that is for adjustment, and then we compute the output, that is the estimate. So having a linear function and non-linear function, both are indispensable part of neural network. So you can't just take away the non-linear part from this unit. So it's like the human brain. So if you have only the right brain and if you don't have the left brain, then that becomes difficult for you to survive. So similar is the case with the neuron. It won't survive, but then it will collapse immediately after a few computations, or neither it will not do any computations at all. So I'll just give you one more example. Say we have some mathematical equations, like we have, say w is represented in terms of ax, then say you have x in terms of by and y in terms of cz. Now I'm asking you to represent w in terms of z. So how would you do that? So first you will take this equation, in place of x you would replace it by by, and in place of y you would represent z. So assume all these ABCs are constant. So say just consider this as number 3 into 2 into 1, that becomes 6. So w is nothing but 6 times of z. So this is a linear function. Now in the real world, say our equation is of form z is equal to w1 x1 plus w2 x cube, w3 x4, and so on, wn xn. If you have these kinds of representations, or this is not a monomial, but this is a polynomial. So if your neural network is not able to learn these things, then it becomes difficult for you to transform or train your neural network in each and every scenario. Then you need to change that architecture which we have seen, and which essentially affects your generalization of a neural network. So learning these kinds of functions becomes essential. So before the era of deep learning, if these things were coming into your equation, then how they would treat is by using something called as feature engineering. So where what they did is they tried to replace this coefficients which were not linear in input. They tried to pass it to some function to make it linear, and then they would put into your function. But in the current deep learning techniques or strategies we use, we don't do feature learning. So feature learning is not, or feature engineering is not a part of current deep learning trends. So all the inputs are considered as linear, and then we do it in some non-linear function by using sigmoid or other functions like ReLU or tanh. So what we mainly see is we have some input layer and we have the output layer, and then we have n number of hidden layers. So up till 1, 2, up till n hidden layers. Say it can be up till any number for the complexity. Now if your neural network is just only learning or just taking the inputs and just multiplying it with the weight vector, then what is the purpose of your neural network? It is not merely learning anything, just it is multiplying and then it is just adding up with all the other bits. So that is just you can do with your simple math also. But in order to learn the non-linearity present in particular dataset, how the distribution is, how it would change in a particular period of time, you need to have this non-linearity part also. So it becomes an indispensable part of your neural network in learning, so that it can learn each and every decision boundary which is there and which is offered by other machine learning algorithms, that is by SVM, or if you have some other curves, parabolic curves, linear regression, decision trees, and many other. So well, that was all regarding the decision boundaries of neural networks. So hope you guys enjoyed this video. If you want to get educated of this video, please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.